Thank you all for coming. My name is Joanna Coleman, and I am very happy to introduce to you Professor David Taylor. So he is currently the chair of the Tropical Environmental Change Research Group and the Graduate Studies Coordinator in our Department of Geography. And before he rejoined NUS, he was the chair of geography at Trinity College, which is part of the University of Dublin in Ireland. And he was the chair of the Trinity International Development Initiative. He also served almost 5 years as the head of the Department of Geography, 3 years as the head of the School of Natural Sciences, and 2 years as acting senior dean. So today, David sits on the European Science Foundation panel of reviewers, the Governing Council for the British Institute in Eastern Africa, and the Board of Trustees of the Mary Robinson Foundation for Climate Justice. He's also a member of the editorial board for 2 journals. One is the Holocene and the other is the Anthropocene. So David's research looks at the human dimensions of environmental change, particularly in Africa and Asia. And his main interest is human-environment interactions in the developing world, especially how the environment or environmental changes, including climate change, can put a lot of pressure on vulnerable societies. So what he does is try to understand these pressures in the relatively recent past and present, and then use that understanding as a basis for policy-relevant, better anticipations of future changes and the implications of those changes. Today, or currently, David is involved in 2 major projects in Africa. Both are externally funded. The first is that he's the lead principal investigator and scientific coordinator of the European Union's framework program, Healthy Futures Project. And that one looks at environmental change impacts on vector-borne diseases, so like malaria, in Eastern Africa. And he also leads a work package, which is part of an Irish overseas development project called Nourish. So what Nourish does is look at the link between malnutrition and low survival of people who are suffering with HIV/AIDS and are being treated with antiretroviral therapies. So this study is taking place in northern Uganda, and one of the important things about the study site in northern Uganda is that there's high food insecurity and malnutrition, and mainly that's because of periodic environmental stress, climate change, and political instability. Another feature of the study area is that these antiretroviral therapies don't seem to work as well there as they do elsewhere, and there could be a link between that ineffectiveness and high malnutrition. So this work package is also looking at the feasibility of using a locally produced, ready-to-use therapeutic food supplement in order to foster nutritional security. And with that, I will let Professor Taylor take over.
Thank you very much, Joanna. Possibly the longest introduction I've ever had. Thank you very much. You're very kind. And thank you all very much for coming along to this seminar on a Friday evening. It's a good turnout. Considering I've lectured quite a few of you, I'm surprised that you've come along to one of my lectures after the experiences you had of me over the last semester. And this also is on the front row here, or not the front row, the next front row, some members of my family, my son Sky and Rowan, partner Poonam, and here in the middle is Peter Sanderson. Peter Sanderson used to be a professor here in NUS. She was in NUS in the late 1990s and returned to Australia and is now Deputy Vice Chancellor of a university in Western Australia. So you're very welcome, Peter, back to NUS. And you're all very welcome to my seminar. I really like this image because it captures, for me at least, what I see as one of the main issues in Africa. This photograph was taken a couple of years ago. It was taken in the country Rwanda, and it was taken by a master's student who was part of a field trip that I was running at the time. It's from northern Rwanda, very close to Volcanoes National Park, which is one of the main locations for the protection of mountain gorilla. And it's a very important place of conservation. It's also a very important place for ecotourism. The photograph, basically, as you can see, shows this lady. Actually, this is one of the most famous backsides in academia now, because for the last 2 years I've shown this same slide all over the world. She doesn't know it, of course, but her backside has been shown widely. But this lady is collecting water from this pond. It's quite obviously polluted. It's got a lot of algae in it. It's suffering from eutrophication, no doubt partly as a result of the fact that this water body is shared with livestock. You can see a cow here drinking water. We spoke with this lady. She'd walked nearly 4 kilometers to collect water from this site. Collected in these jerry cans. These jerry cans, old jerry cans, plastic jerry cans, cracked, leak. By the time she gets back to her house, quite a lot of the water she's collected has been lost. She doesn't use the water for washing in. She can't afford to use the water for washing in. She only uses it for drinking and cooking. The water that they drink, her family drinks from here, they drink untreated. She can't afford firewood to boil the water. She can't afford any form of filtration system or tablets that treat the water or whatever. She knows that drinking the untreated water is likely to make her family ill. So it's not a problem of being uneducated or of not having enough information. There's no information deficit problem here. It's simply an economic issue. She can't afford to treat the water. I think it captures a lot of what I see as an essential problem of environment and development in Africa, because Rwanda is one of the world's fastest growing economies. Over the last 10 years, Rwanda's rate of economic growth, GDP growth, has approached 8% per year. That's year after year after year for the last 10 years. One of the world's highest rates of economic growth. That economic growth, however, has not translated into poverty alleviation, and it's not translated into protected environments. That economic growth has been largely driven by external forces, external factors, notably ecotourism. So this eucalyptus plantation is by the side of the lake is linked to a tourist lodge. The wood is not used by local people. It's used to heat bedrooms in the tourist lodge, where tourists are paying up to $1,000 a night to stay. This lady can't even afford firewood to boil the water that she gives to her family. The other issue here is something I'll come back to as well. Here she's sharing a water resource with livestock. It's a classic case of how easy it is for diseases to jump between animals and humans. Little surprise that these kind of areas are the kinds of areas where infectious diseases are likely to emerge in the future. Classic situation where animals and humans are sharing the same resources through necessity. Okay, so I want to start with Africa. This is what I've been doing work on in Africa. I did my PhD in Africa. I've been working in Africa for about 30 years. And notice I'm using the term Africa. And a lot of people treat Africa as a homogeneous unit. I've even had students here at NUS refer to the country of Africa. So Africa is very much, in many parts of the world outside of Africa, the dark continent. Metaphorically, because we don't really understand it, we don't give it much thought. But also, as you can see, literally. So this is Africa at night. You can pick out some of the main urban areas: Cape Town, Johannesburg, I guess this is Nairobi, Mombasa, Kampala perhaps, the Lower Nile, Cairo. But most of the continent is dark at night. Many parts of the continent still lack electricity, or people still can't access electricity. This is an important point actually. Many of the countries in Africa, there's been very extensive rural electrification projects over the last decade or so. The problem is that many people in rural areas can't actually afford electricity. So it's not the fact that there's no electricity there. It's quite common to see pylons and electronic cables now running through rural areas in many parts of Africa, but people can't afford the power. Okay, question to you guys. Those of you who had lectures with me, you'll know that I like to ask questions and I get really angry if you don't answer them or if you answer them wrongly. People refer to Africa often in the singular. How many countries are in Africa? Anybody like to hazard a guess? Hey, well done, yeah, 54 countries. Very good. I wasn't expecting that. South Sudan was the 54th country. So when we're talking about Africa, actually we're obscuring a huge amount of environmental, human, cultural and natural variability. 54 countries, lots of diversity. This is a map of global linguistic diversity. It's from a paper that was published last year in PNAS. Got to be very careful how you say that, of course, the journal PNAS. And you can see that Africa is one of the most diverse places linguistically. Linguistic diversity is linked to cultural diversity. This paper actually is very interesting because it links cultural diversity with biodiversity. So we're talking about a very diverse continent, diverse in terms of cultural diversity, but also diverse in terms of biodiversity. Africa contains all or part of about 25% of the world's biodiversity hotspots. Biodiversity hotspots are those parts of the Earth's surface where there's unusually high levels of species diversity, and particularly among species that are not found elsewhere. Africa has a substantial share of biodiversity, and really only Southeast Asia and Southern Asia comes close to matching it. You've seen this image perhaps from the circular that I've sent round. A lot of people, when they think of Africa as a relatively insignificant place. Few people would think that the African continent with those 54 countries is larger than the combined size of China, India, the US, Eastern Europe, Italy, Germany, France, Spain. It's a huge area, and yet we're quite happy to talk about Africa as if it was just a single entity, homogeneous entity. And of course, within Africa, we're talking about development. There are some very relatively rich countries. Some of the North African countries, relatively rich. South Africa is relatively rich. Even within some of the poorest countries in sub-Saharan Africa, there are rich people. And so those of you who've heard of the Gini coefficient, Botswana, Gini coefficient basically is an indication of the discrepancy between the richest people and the poorest people. The country with the highest Gini coefficient, anybody got any idea what country that is? Botswana in southern Africa. Some people in Botswana are extremely rich. The poor in Botswana are amongst the poorest in the world. Often when we think about Africa as this homogeneous unit, we also think of it as in terms of a bit of a basket case. So the kind of images we have of Africa are of it as being like a threatening place, and that people in Africa spend their lives dealing with drought, famine, shortages of water, environmental pollution. we also perhaps tend to think, why don't those people do something about it? Why do they tolerate it? Almost as if it was their own doing that these problems exist, and this is the environment in which they choose to live. I just want to show you some real data, however, and these real data are data that are collected by the Centre for Research on the Epidemiology of Disasters. It's CRED. It's based in a Belgium university. They have a big database where they collect information on this is the website. They collect information on the occurrence of disasters, and a disaster is defined as an incident that overwhelms the local capacity to cope. And so this is regarded as being an objective or relatively objective database. And by that I mean that it's not a database that's funded by the insurance industry. So the insurance industry, of course, would probably like us to think the world's a very, very hazardous place, and therefore we would insure against the risk of things like disasters. And therefore perhaps we couldn't trust them to collect data objectively. So this is not funded by the insurance industry. It's funded by independent organisations, the Belgian government, USAID, United States Systems for International Development, etc., etc. So these are data taken from the most recent annual statistical review of the incidence of disasters, and it was published last year, and these are data from 1990 up to 2011. The blue histograms relate to the number of people affected by disasters, either killed or they lose something. They might lose their house or lose some property or whatever. And this line here is the number of reported disasters, and you can see there's a bit of variability. I just want to draw your attention to the year 2007. Not an unusual year as far as disasters go, either in terms of the number or in terms of the number of reported disasters or in terms of the number of victims. This is that same data for 2007 but expressed globally. And so here we have the number of disasters reported for different countries in different parts of the world. And really what I just want to emphasize here is that actually for 2007, it's not an unusual year, Africa doesn't actually experience many disasters. There are more disaster-prone parts of the world, the US, parts of Asia, China, India. Africa doesn't experience many. But when it experiences disasters, what tends to happen is that lots of people lose their lives, or lots of people are impacted. So this is the same data, but now expressed in terms of number of people affected, reported victims of disasters for the same year. And we can see that although there are relatively few actual events, what tends to happen when an event occurs in Africa is that lots of people are affected. So in Africa, when there's a disaster, people don't tend to lose their cars, they lose their lives. Another interesting feature of disasters in Africa when compared with other parts of the world is that because Africa is a largely stable continent, a bit like Australia, it doesn't tend to experience volcanic activity or earthquakes to the same extent as other parts of the world. Of course, there is rifting in Africa. We're all familiar with the Eastern Rift Valley and the western arm of the Eastern Rift Valley. But that rifting occurs on a relatively slow pace. It's not the sudden rips that we see or hear about in Asia, for example. So this is a distribution of disasters around the world, different continents. But here, the triggers of those disasters are divided up into different types. And this is the typology that's used by the CRED database. So I'm not particularly happy with this typology, I'm just reporting it to you. And basically, they divide up the cause of disasters into the natural causes of disasters into two groups. Geomorphic, geophysical, kind of earthquakes, volcanoes, and climatic. And basically, it shows that in Africa, if a disaster occurs, it generally has a link to climate. It's either a drought, it's a flood, it's anomalous weather conditions. And that's a main reason why in the fourth assessment report for the IPCC, the Intergovernmental Panel on Climate Change, Africa was identified as the world's most vulnerable continent to climate change. But there's another Africa that I hinted at the beginning of this presentation. That other Africa is one of success, one of economic success. Urbanization is proceeding at a rate in Africa faster than anywhere else in the world. More people are moving to cities in Africa than anywhere else in the world. Of course, that presents its own problems. People who live in cities generally have more sedentary lifestyles than in rural areas. It brings health consequences, etc., etc. There are now more than 50 cities in Africa with populations of greater than 1 million. To look at, and these are IMF and Economist data. These are GDP growth rates. The countries in bold are African countries. These are the world's top 10 countries with populations of greater than 10 million. Top 10 countries in terms of GDP growth over the 10 years from 2001 to 2010. Many of you might be surprised to see such a large number of African countries, especially given that this period also includes the credit crunch and the financial crisis in Europe. Looking into the future, up to 2015, again, prominence of African countries, Ethiopia, Mozambique, Tanzania, all posting high levels of GDP. And so there are people out there who are very positive about Africa, about its development, who will show data that suggests that Africa's collective GDP is expected to more or less double between 2008 and 2020. Asian countries are, of course, heavily involved in this. We hear a lot about China's role in Africa. We hear also about Korea and Japan and their role. We perhaps hear less about India, but India is increasingly a major player in Africa. So between 2000 and 2010, trade between India and African countries increased by a factor of 15 times, from $3 billion in 2000 to $46 billion in 2010. What characterizes these links, however, is exploitation. So these links tend to be based on resources. These are countries that see Africa as a useful source of resources. Those resources might be mineral, such as diamonds, for example. So this is Zhuaneng diamond mine. My younger brother used to be the production manager of Zhuaneng. I went to visit him once in Botswana. So many people don't know that the diamonds that some people are so attracted by and interested in are associated with huge environmental costs. Now, obtaining them is associated with huge environmental degradation. So some of the biggest holes in the world are dug in order to get diamonds. These are the same diamonds that can be produced industrially. Same quality, or you wouldn't be able to separate them from the diamonds that are won through these kind of mining activities. Actually, De Beers, which is the company that my brother used to work for, one of their biggest fears is that people would wake up to the environmental destruction that's caused by producing diamonds. Just in the same way that 40 or 50 years ago people woke up to the fact that actually furs aren't that good looking, they look much better on the animal than around somebody's neck, and therefore people stopped buying furs. De Beers is really concerned that people stop buying diamonds if they realise just how much environmental destruction is caused by taking something from the ground that could be produced industrially to the same quality. So it's an exploitative relationship. And there are many factors facilitating this level of exploitation. One of them is that many African countries now have very liberal economies. They were forced to open up their economies during the 1980s and 1990s by the IMF and by the World Bank through a process of structural reform, structural restructuring of the economies. And basically it was in response to high government debt. So a lot of government offices were closed, conservation bodies were closed, forestry departments were closed, schools were closed, etc., etc. Labour laws were radically reformed in order to open up the economies to external investment, foreign investment, and industrial development. So that's one factor. A second factor is that most of the land is state-owned in many African countries. What that means basically is it's very easy for governments to expropriate resources. It's very easy for governments to take land and to give it to overseas investors. At present, one of the main countries involved in the expropriation of land in Africa, and this is land in many cases that's been used by local people to grow crops, is India. So India is maintaining or boosting its food security by taking land and resources from one of the most food insecure parts of the world. Abundant resources. Africa, we hear a lot about oil, gas, diamonds, other minerals, forests. I was reading a report just recently that said that Africa currently has about 60% of the world's uncultivated land, and this was being advertised to external investors. And I wondered what they meant by uncultivated land, because uncultivated doesn't mean it's not being used, doesn't mean that it's not supporting livelihoods. So this is uncultivated land, but people are using it for as a source of food. We also hear terms like marginal. So these countries that are involved in investing in a big way in Africa are developing marginal land. Marginal in whose eyes? Is this marginal in the eyes of people who are in an office in London or Delhi or Beijing? Or is it marginal in the eyes of the people who are actually living there and trying to eke out a livelihood? And so this goes back to the point that I was making earlier, is that impressive GDP growth that these countries have doesn't necessarily translate into poverty alleviation. And in fact, it could be argued that the causes of this impressive GDP growth in many African countries are actually adding to these problems of poverty and food insecurity through the nature of that development. So I just want to show you a little video clip here. Rowan's going to be very impressed. Okay, so this is the International Human Development Index, and I'll just get it up on the screen if I can. So this is a composite index of development. So it goes beyond simply GDP. So the Human Development Index incorporates not just income, but life expectancy, incorporates How many years somebody who's reached the age of 21 is likely to have spent in education? How many years in education somebody who's just been born is likely to spend in education? There's a whole kind of combination of factors. And what I wanted to show you is just, so Singapore is about 20th in the world in the Human Development Index. The lowest index is Congo, DRC, Democratic Republic of Congo. The highest is Norway. So in Norway, there's lowest income discrepancy, highest life expectancy, or amongst the highest life expectancy. People spend a long time in school and university, etc., etc. So I just want to run this video. So this shows how global HDI has changed over the last 20 years or so. And I just want you to keep your eye on Africa in particular. That's really impressive, Rowan, isn't it? I'll just run it again. Basically, you'll see that the countries in grey are countries with no data. Large parts of the world go darker and darker blue. Those are countries where the HDI is increasing. Things are getting better. Livelihoods, well-being, etc. is getting better. But look at sub-Saharan Africa. It doesn't change at all. So these countries that are posting these really high rates of growth, it's not being translated into improved human well-being. I mentioned that the causes of this high growth is also possibly contributing to problems, increased environmental problems, maybe increased impoverishment of society. Because the nature of this exploitation, high rates of exploitation, is that it's leading to environmental degradation. It's associated with deforestation. You can see this. This is from the Global Forest Assessment report from 2010, produced by the FAO. You can see that rates of deforestation in Africa over the last 20 years are on a par with those in South America, despite the fact that Africa doesn't have much forest, nowhere near as much forest as Amazonia. Here we can see that these biodiversity hotspots that I mentioned earlier on are being squeezed by high population growth. So this map is the world scaled according to rates of population increase, and then superimposed upon that map are these biodiversity hotspots. And basically what this means is that people are being moved into smaller and smaller areas where they're coming into closer and closer contact with wildlife, and that's creating conflicts between wildlife and people who are trying to cultivate, who are still trying to cultivate. I mentioned at the beginning that we often wonder why people put up with this. What is it? Why don't they try and stop it? But actually, in many, many cases in Africa, in African countries, people do try and stop this. The problem is they don't have connections to the people who make the decisions, the decision makers. And a lot of this is remote from us. We don't really know that it's going on. We don't follow these things. Good example is Mabera Forest in Uganda. Mabera Forest was set up as a forest reserve in the 1930s. It's the largest remaining fragment of forest in southern Uganda. This is Lake Victoria. About 5 years ago, the Sugar Corporation of Uganda, that's jointly owned by an Indian company, but also by the government of Uganda, was given 70 square kilometres of forest to convert into sugar plantation. This is not sugar for use in Uganda, it's sugar for export and use in India. How did the local people react? Well, the local people reacted very strongly. There was riots in Kampala. There was some killings in Kampala. Indians were attacked. Members of the Indian population were attacked. Local people got together and offered this Sugar Corporation of Uganda 100 square kilometres of agricultural land, existing agricultural land, to use as sugar plantation rather than taking their forests. They actually offered more land, of their own land, for the Sugar Corporation to use rather than their forests. The Ugandan government's response to that was to take the 100 square kilometres of land and to press on with clearing 70 kilometres of forest to actually create an even bigger sugar plantation for exporting even more sugar to India. And this is just a couple of images from the press in Uganda, just to give you an indication that that this deal wasn't supported locally. There's a lot of strong resistance to it, but that resistance was overruled. This is interesting because Mabera Forest is one of the few places now in this part of Africa where the plant Citropsis articulata is found, the tree Citropsis articulata. It's a natural form of Viagra, and apparently it's used quite widely by members of the Ugandan armed forces. And so this is quite a nice cartoon from one of the newspapers with a play on words where they're suggesting that the Ugandan army that's addicted to this natural Viagra is being done out of its source of natural Viagra by the dictator Yoweri Museveni, who's the president of Uganda, who got to power basically through his close contacts with the army. The point here is that these things are not just accepted. These people in these countries contest strongly these developments because they know the implications are not so good for them. On past experience, they know that these things often lead to their further impoverishment, further environmental degradation. Okay, so I just want to finish off by talking to you about health very quickly, because I realise I've not got much time. And in particular, health in Africa. I'm going to go back to this issue about Africa being the world's most vulnerable continent to climate change, and look in particular at implications for health. So this is the world's, I love these maps, this is the world scaled according to public health spending. So the big countries are where lots of money is invested in health. Lots of money is invested basically in making or enabling people to be resilient to stresses. Sub-Saharan Africa, virtually no money is invested in public health because there's very little money to invest generally. Not surprisingly then, when we come to scale the world according to the number of infant deaths, that Sub-Saharan Africa, with so little investment in public health, comes out very much on top in terms of, or along with Southern Asia, in terms of numbers of infant deaths. Just bear in mind what I said earlier on about the cause of many disasters in Africa are climate. This is the world scaled above here according to CO2 emissions. So these are cumulative. This is from a paper that was published in Lancet in 2009. This is the world scaled according to accumulated CO2 emissions over the last 50 years or so. So although Africa is the world's most vulnerable continent to climate change, if we accept that quite a bit of climate change is being caused now by greenhouse gas emissions, we can also see that actually particular Sub-Saharan Africa is responsible for very little of that climate change. So there's a justice element here. This lower figure is the world scaled according to climate-related diseases. And here, climate-related diseases such as malaria, cholera, etc., and their prevalence in Africa in particular give Africa this huge size. I think it's really remarkable, incidentally, and I'll come back to talking about malaria shortly, but for malaria, for example, malaria is a disease that we know what causes malaria. we know how to prevent it, we know how to treat it. Each year, more than 500 million people are infected by malaria. Each year, 1.25 million people die from malaria. 90+% of those people live in Africa. The vast majority of those people who die are pregnant women and children. I think it's remarkable that we continue to allow this to happen. Anyway, so we know that many health issues can be related to the environment. So here I'm going to make a big plea for a more preventative approach to disease rather than the more expensive route through curing. So these are some of the world's major diseases, and these histograms basically show the extent to which those diseases can be explained by environment. So for some diseases, such as diarrheal diseases like cholera, a very substantial proportion of the disease can be explained by environmental conditions, more than 90%. So here we have on this histogram, just to explain, about 4% of the global disease burden is linked to diarrhea, and about just over 90% of that 4% has an environmental link. Malaria, lower respiratory diseases also have a strong environmental link, and some members of society are much more vulnerable with regard to environment-related diseases than others. So children and old people are particularly vulnerable. Children under the age of 14 are 44% more likely to die as a result of environment-related illness than the general population. So we have a strong environmental control on diseases. We have a continent that's particularly vulnerable to environment-determined disasters, particularly those linked to climate change. So we must have a concern about what's going to happen in the continent of Africa looking into the future, particularly if economic growth, although maintained, doesn't seem to be translating into environmental protection and reduced poverty, etc., etc. And there's lots of evidence for environment changing in Africa. This is wetland rice development in Rwanda. Basically what this is doing is creating a new habitat for malaria mosquitoes and other vectors of infectious diseases. We know from data now, meteorological data, that climate is changing in Africa. So these are meteorological data from the tea estates in Kenya, which show that over the last 3 decades or so, temperature has been increasing by about 0.2 degrees centigrade per decade, and that increase seems to be speeding up. Incidentally, one of the problems of doing climate-related research in the continent of Africa is a lack of climate data. And to some extent that problem was caused by this structural readjustment that I mentioned earlier on. The IMF and the World Bank in the 1980s and 1990s basically forced governments to close down many of the organizations that were involved in collecting data, that were involved in environmental monitoring, that were involved in environmental protection. So these are basically a number of meteorological stations in Eastern Africa, going from 1920 up to about 2005. These images were published in 2011 in the Malaria Journal, and you can see 1970s, 1980s, lots and lots of meteorological stations collecting temperature, collecting precipitation, and then in the 1980s, 1990s, things just drop off completely. And now, as a result, it's actually really difficult to do climate modelling in this part of the world. We just don't have the data. It's really difficult to look for trends in the data because there are these major gaps. We know that many vector-borne diseases, in particular such as malaria, have a strong link with environmental conditions. So So these are real malaria data from West Africa. This is the malaria data, malaria incidence data, plotted on a weekly basis. So for 3 years, 2001, 2002, 2003. These are precipitation data. And you can see there's a strong resemblance. But there's an offset. So you have the rise in precipitation with the wet season, and following that by about 2 or 3 weeks you have a rise in the occurrence of malaria in the same location. And the connection, of course, the link is these are pools of water that form during heavy rain, and these pools of water are the habitat for malaria mosquitoes. And it takes a while for those pools to form and for the pools to be colonized by the larvae of mosquitoes, and then for those larvae to hatch, etc., etc. So it's not a direct relationship, but also you can see from this green curve in particular that there's a leveling off. So it's not a linear relationship either. So you have the increase in malaria as it gets wetter, and then it begins to level off. Anybody got any idea why that might be? What do you think might be happening there? Could be intervention. I don't think it is in this case, though. So the reason I'm saying this is because I'll very quickly in a minute go through some modelling work that we've been doing. And these are one of the problems of trying to model these diseases, that many of the relationships are complicated by socioeconomic factors, but also by other factors as well. So here I think what's happening is that, well, for a start, if you have a big pond of water like this, well, that's not so big. It will be largely available habitat for the larvae of mosquitoes. But bigger than this, and the mosquitoes don't fly into the middle to leave their eggs. They just leave their eggs around the margins. So there's a point where surface water gets to the stage where adding more surface water doesn't increase so much the habitat for mosquitoes. The other factor is if you get more and more rainfall, then you get faster and faster river flow. And that faster and faster river flow washes away mosquito eggs and larvae. So there's a relationship with rainfall, but it's not simple. It's complicated, and that has implications for modelling. There's also a relationship with temperature. Again, these are real data. So this is increasing altitude. This is incidence of malaria. These are data from Kigezi in southwestern Uganda. As you increase altitude, you're basically reducing temperature. As you go higher and higher, it gets cooler and cooler, and malaria incidence declines. And there's a lapse rate, which we can plot. And again, it's not a simple function, it's not a simple relationship, but there is a relationship there. So this is some work that Menno Buna did, one of my colleagues, and he basically plotted this relationship on population data for Eastern Africa. So basically in Eastern Africa, you get most of the people living at middle and higher altitudes. So you get higher population levels from about 1,500 or between 1,500 and 1,900 meters above sea level. One of the reasons for that is that it's a disease avoidance strategy. People don't live in lower lying areas because that's where diseases such as malaria are endemic. However, if we warm the temperature, and again this is very simple, but it's good just to demonstrate. If we warm the temperature, this lapse rate basically shifts to the right. As it shifts to the right, it brings malaria into contact with more and more people. Perhaps more importantly, those people who now come into contact with malaria as a result of this warming and the shift of the lapse rate to the right, those people lack immunity, or they have reduced immunity. And so these are classic conditions for epidemic malaria, the kind of malaria that kills people, basically. If you warm the temperature by 2 degrees, it moves even further to the right, brings even more people into contact, people who don't have immunity to malaria. So when we're talking about safe climate change, and we're talking about climate change of maybe 1.5 to 2 degrees centigrade, we should keep in mind that in this part of Africa, a 1 degree C increase in temperature could possibly increase the burden of malaria by more than 100%. This is a disease that already kills over 1 million people, most of those living in sub-Saharan Africa. With 2 degrees C, then that disease burden is increased possibly by as much as 250%. And this is what we regard as safe climate change in places like London and other countries that are negotiating climate change agreements. Okay, I can see my sons are dropping off to sleep, so I'm going to have to speed up. So I just basically want to finish off just by quickly. You'll be relieved to know these are my kind of timekeepers. When I see them falling asleep, a bit like canaries in a mine. When they start falling asleep, I know it's time to go. So I just wanted to finish off by telling you about the project that John mentioned at the beginning. This is this Healthy Futures project. It's a big project. Includes now comprises 16 organisations, including NUS. It's focusing on Eastern Africa, and we have two broad aims. The first aim is to try and better understand these links between environment and diseases such as malaria, vector-borne diseases in particular. The second broad aim is to use this improved understanding to try and better, I won't say predict, but try and better anticipate what future disease burdens might be. So basically to set up, if you like, an early warning system that health workers in the region can use to tailor their practices, bearing in mind that they're very cash short, they're very financially restricted, so they can make most effective use of their limited financial resources. This is the website. You're welcome to visit the website. This is this woman's backside again. She's kind of even more famous. This I'm sure this the number of hits on this website is linked in some way to the photographs that we have on the website and less to the research that we talk about. We're working in Eastern Africa. We're adopting a regional approach. So we're looking at disease burdens in Kenya, Uganda, Rwanda, Burundi and Tanzania. This is the East Africa Community region. It's the equivalent of the European Union, but in Eastern Africa. We're looking at 3 diseases in particular. They're commonly referred to as vector-borne diseases, but only 2 of them actually are vector-borne diseases. That's malaria and Rift Valley fever, which is a zoonosis. The zoonosis, those are diseases that jump from animals to humans. Schistosomiasis is otherwise known as bilharzia. It's a problem in about 80 countries around the world. It's a big problem in China at present. Schistosomiasis, although it's referred to as a vector-borne disease, actually has an intermediate host, which is a snail, rather than a vector, strictly speaking. And these are some of the places where we're working. This is the very beautiful Lake Barera in Rwanda. This is close to the border with Uganda. This is where we're doing some work on Highland malaria. So Highland malaria is epidemic malaria. It's that really dangerous malaria because it tends to impact people who lack immunity. So most of us here in this room will lack immunity to malaria. So if we go to one of these places and get malaria, there's a good chance it will be serious malaria. There's a good chance it will be very harmful to us. We might die. We'll certainly be very ill. In areas where endemic malaria occurs, where malaria is there and is occurring all through the year, every year, people who live in these areas build up some immunity to the disease. So when they contract malaria, it tends not to have such an impact on them unless they're pregnant or unless they're very young and they have not acquired sufficient immunity. The interesting thing about malaria, one of the interesting things about malaria, is that people lose their immunity really quickly. So if you move people from an area, or if people from this area, an endemic area of malaria, go to America for 2 or 3 years and then come back, they've lost their immunity. So they're extremely vulnerable, just like we are. If people use bed nets and in these endemic areas, and they're not being bitten by mosquitoes, they're not being infected with malaria, and then after 2 or 3 years, and this is what's happening in many African countries now, if after 2 or 3 years they stop using the bed nets because they don't seem to have malaria anymore, then they start again from scratch. And they've lost their immunity and they're extremely vulnerable again. So if you look at some of the malaria data in parts of Africa now, you see there's a big increase, then there's a plateau, people started using the bed nets, and people get complacent, stop using the bed nets, and malaria goes up again very, very quickly. So anyway, this is one of those areas. This is a schistosomiasis site, which is Lake Albert, one of the Rift Valley lakes in Uganda. This looks like the sea, doesn't it? It looks like, a bit like the coast. It's an inland, it's a lake, a freshwater lake. And this is the site for Rift Valley fever in Kenya, close to the border with Somalia. A semi-arid area, rainfall is very highly seasonal, and the Rift Valley fever outbreaks are associated with that seasonality. Very quickly, I know we've got to press on. This is really just to emphasize to you how complex these relationships are. So what we've been trying to do, one part of Healthy Futures, is to try and model diseases, but not in a way that's traditionally been done, where people have tried to just establish empirical links between the occurrence of a disease and environmental parameters, variables such as temperature or water. We're actually trying to model the actual disease and the behavior of that disease and the processes that affect that disease, processes such as immunity, socioeconomic conditions, people's mobility, other environmental factors such as topography. So it's not just the water, it's not just about the water, the surface water, it's also about the surface topography, etc., etc. And it's a complex job because these are really quite complex diseases. And as we're finding in this region with dengue, very, very difficult to model. So this is the kind of traditional approach to modelling diseases, using these empirical models. They make really nice slides for presentations. Often their scale is not of much use to people who are trying to use these data, who might use these data, like local health workers or whatever. So these might be useful for showing how globally malaria incidence, in this case, might change over time with climate change, but actually they don't really mean very much. And these are models that are based on empirical relationships. So it's malaria incidence just modelled against rainfall or temperature and how those variables change into time. What we've been doing is developing these dynamic models, and this is one of the models that we've developed for malaria. It's called Vector. It's just been published in the Malaria Journal. It's a dynamic model. I was going to spend a bit of time explaining the actual structure of the model, but I won't, just to say that at present we have the model operating on a 10 kilometre by 10 kilometre grid scale. We can increase that resolution down to about 1 kilometre. There's no point taking it beyond there because it just becomes a bit of a pointless exercise. Actually, most health workers want to use this information on a scale of about between 1 kilometre and 10 kilometres. Anything less than that and it just becomes meaningless, especially as the malaria mosquitoes can travel. An individual mosquito can fly for about 1 kilometre anyway. So anyway, the model, the Vector model, is basically incorporates larval development, the factors that influence larval development, things like temperature, water, density, and the numbers of larvae. The actual development of the pathogen within the adult female mosquito, and then the likelihood of a host, a human, being infected with a mosquito, with malaria. So very, very quickly, just to finish off, just to show you some data. This is Rwanda, just to show you the topography of Rwanda. So basically this is the Nile-Congo divide. Water draining this way drains into the Nile, water draining this way drains into the River Congo. So it's an upland area, it's a ridge that runs through Rwanda. These are malaria data. incidence data for the year 2010, and you can see that the most of malaria, the darker colours, is the higher malaria incidence around the borders of Rwanda. These are the endemic malaria areas, generally the lower altitude areas. There's another factor here, and that's that people from south of Rwanda, Burundi, and from Tanzania and from Uganda, living close to the border with Rwanda, tend to travel into Uganda to be treated by malaria. So that's another reason why we pick up these higher incidence levels, because the Rwandan health service is regarded as being better than health services in these adjoining countries. So this is one of the complicating factors of the health data that we have access to. But just to emphasise that this upland area doesn't tend to have much in the way of malaria, but there are some pockets where malaria is relatively high, even in these upland areas. So this is the vectory output, this dynamic model output. So this is not a statistical relationship, this is modelling the behaviour of the disease. So it's much more complicated than simple empirical relationships, statistical relationships. And the paler colours indicate areas of malaria incidence. The blue colours indicate areas where malaria doesn't occur according to vectory. So this is trying to model current conditions as a way of basically checking how accurate or not the model actually is. And this is what standard procedure in modelling. This is what we need to do before we can have any confidence about running the model into the future or under different environmental socioeconomic conditions. But you can see it's picking out pretty well the areas of high malaria. But one thing the current version of this model lacks is a surface water function, and that's what we're developing at present, a module that will model surface water availability for particular conditions. And we think that the reason at present that vector isn't picking up these isolated hotspots of malaria in these upland areas is because these are areas where wetland has been developed for agriculture. So it's basically introducing malaria into upland areas. This is providing suitable habitat for malaria mosquitoes. It's water, there's a drain, rice, surface water. But there's another significant change here. These were formerly papyrus swamps. And the papyrus plant produces an oil. And that oil actually seals the surface of any standing water. And malaria mosquitoes, and indeed most mosquitoes, can't breed. Their pupa, their larvae can't survive under those conditions. They can't breathe when they're in the water. You clear the papyrus to produce rice, and you open up the whole system to the possible invasion from vectors such as the malaria mosquito. And I just want to finish, because I've mentioned to you about the external drivers of change in Africa. Africa is considered by those companies, and there are not many African companies amongst them, those companies that like to build dams. It's considered a relatively undammed continent. And so just about every single major river in Africa now, there are several plans to build several dams. Much of the funding for that dam development is coming from what used to be called the Clean Development Mechanism, the Green Climate Fund, linked to climate change mitigation, international funding. So whilst this will no doubt bring certain forms of economic development to these parts of Africa where these dams are being built, irrigated agriculture, hydroelectric power, based on past experience we will know that there will also be significant numbers of people who will not receive many of the benefits of that development. But at the same time, these developments also have health implications, because these irrigated systems, these dammed rivers, are prime breeding sites for vectors of diseases such as malaria. And I'll leave it there because my son's just about to go to sleep. Okay, thank you very much. Thank you. Oh, sorry, this is, Joanna mentioned my work in northern Uganda. I was in northern Uganda just before Christmas. And this is an image from Kidepo National Park, which is right on the border between northern Uganda, northwestern Kenya, and what is now South Sudan. It's an absolutely beautiful location. And as I mentioned to the first years in the BES class that I was teaching, I'd be interested in running a field trip out to these areas for students. I mean, they're relatively safe areas to visit. Yeah. Okay, this is a water buck. Beautiful animal.
Is there anything positive that's been done already that's been successful for the environment on vulnerable populations that you know of?
That's a really good question. Of course, there are some really positive stories from the region. One of the problems is, I think, is that I'm really interested in political ecology. And from a political ecology perspective, there are very few environmental problems that have simple answers, basically, simple solutions. Many of the problems that we see in Africa have causes that are proximate to those problems. So it's things like high population levels, things like poor governance, corruption. But also, a lot of the contributing factors are outside of those countries. They're in those countries that are buying the timber. They're in those countries that are profiting from the development of dams. There are those countries that are buying the sugar. India is on record as saying that it's solving its food security problems by investing in Africa. So there are some really impressive things happening in Africa, but you do feel that without wider support and a better understanding of what Africa is, its diversity and its challenges and its opportunities, without that wider support and better understanding, then it's going to be difficult to change these other factors. The factors that people in Africa have very little control over. I mean, climate change is a prime example. I was at the climate change negotiations in Durban a couple of years ago. And many African countries had extremely small delegations. They couldn't afford to have many people at the climate change negotiations. They were in a bad position to negotiate because of the relatively small number of people and relatively low level of expertise overall. You compare that with Brazil. Brazil had 600 people in their delegation. 600. The European Union had a similarly large delegation. And so it seemingly all of these kinds of international negotiations, Africa is often very poorly represented. Partly because of the countries involved can't afford to send many representatives, but actually the regional bodies in Africa are also very poor. So the African Union, for example, the East Africa Community, they're not very powerful. It seems to be a problem with many governments of African countries working together. So their voice doesn't seem to get heard at these big meetings. So although there's some really good things going on in conservation, they're fantastic. Africa is, the reason it's got such high biodiversity is because African people look after their animals. Not like people in Europe who killed all their animals and chopped all the trees down thousands of years ago. But, so there's some really great things that we can learn from these areas as well. Yeah, that's another good question. The Gates family, Bill and Melinda Gates, have pumped a huge amount of money into research on some very kind of highly visible diseases. Malaria is one, HIV/AIDS. There's been some problems with that. One of the major problems has been that it's actually led to the emergence of a whole group of diseases known as neglected tropical diseases. Schistosomiasis is one of those. Those are diseases that are under the radar. We hear a lot about malaria for good reason. It still kills a lot of people. Money's been poured into trying to deal with malaria. To some extent, though, that money doesn't seem to be being spent particularly effectively. I think things have changed in some countries, but there are still some really underlying problems. So, for example, a lot of that money Bill and Melinda Gates funding for malaria has been spent on providing insecticide sprayed bed nets. A lot of those bed nets are actually used for fishing. They're used for carrying food home. When I was in northern Uganda, I visited a hospital, the children's ward. There was no mosquito nets in the children's ward. I said, this is crazy. This is the malaria area. The mosquito nets have been stolen and were being used to carry sorghum down to the market. So there's a lot of investment, but that investment doesn't seem to be having a long-term impact. Another case is that the insecticide that's used to impregnate those nets is based on chemicals that have been used as insecticides, pyrethroids, for 50 years. And there's a lot of evidence now that the mosquitoes are building up tolerance to those insecticides. There's also evidence, incidentally, that the mosquitoes, they're very clever organisms, much cleverer than humans in many respects, that they're actually changing their behaviour. So now, rather than trying to bite, these are the female Anopheles mosquito that carries the malaria pathogen. Rather than trying to bite at night, they're biting earlier in the day when people aren't protected by bed nets. So there's been a huge investment, and people talk about vaccines for malaria. You talk to the actual people who are trying to develop those vaccines. One of the major problems they face is that the mosquito, the pathogen, the behaviour of the mosquito, its biology, is changing so quickly. They're finding it difficult to. It's like an arms race. They're just finding it very difficult to keep up. So there is that problem that they're dealing. There's a lot of money being spent. It's not being spent very effectively. There are particular problems with malaria when it comes to treating malaria because of the nature of the disease, the nature of the vector. But there's also this issue that it's leading to this emergence of this category of neglected diseases that are just not fashionable. Everybody wants to find a cure for malaria, a malaria vaccine, because it's probably going to be worth quite a lot of money to them. Schistosomiasis, not there. I'm really tired. I'm really hungry. Thanks to everybody for coming along and for staying so late as well. Thank you very much. Thank you.